This question is asked in GATE 2023 of electrical. This is from signal system subjects and based on, you can say, application of Laplace. The question is, a continuous time system that is initially at rest is described by this differential equation where xt is input voltage, yt is output voltage. The impulse response of the system is, you can think of it's a control system problem or signal system or network, it's up to you. So we are given with a differential equation, first order differential equation. We are supposed to find the impulse response of the system. So what I'll be doing is, so what is impulse response, by the way? Impulse response is h of t, it is denoted by, and this is Laplace inverse of the corresponding S domain function h of s. So what is h of s? So h of s is nothing but it is ratio of output to input if the system is at rest. So first what I'll be doing is I'll be converting this equation into its S domain model. So dy dt of yt in S domain, it is s into y of s plus 3y of s is equals to 2 into x of s. So if you take y of s as common, it is s plus 3 and this is 2x of s. So this implies y of s divided by x of s. So this happens to be 2 by s plus 3. And this is your h of s is. If this is your h of s is, what is the corresponding time domain function? It is 2 into e raised to power minus 3t ut. Because 1 by s plus a having inverse Laplace e raised to power minus at ut. So this function will have the inverse Laplace 2 into e raised to power minus 3t ut. If you see, this is satisfied by option C. So C is the right answer for this problem. This question is asked in GATE 2023 of electrical. This is from signal system subjects and from sampling topic. The question is, a signal x of t is sampled at 200 Hz and then passed through an ideal low pass filter having cutoff frequency of 100 Hz. The maximum frequency present in the filtered signal in Hz is dash. Okay, so by default we'll assume the ideal sampling, and if you remember the block diagram of ideal sampling, it is something like this. We have a multiplier and here this is a impulse train x del t, and this is what is the input signal that has to be sampled, and this is what the sampled signal, the multiplier output is sampled signal. This sampled signal is passed through a low pass filter and the cutoff frequency given is 100 Hz. Now the question they are asking is, so what is the maximum frequency present at the output of the low pass filter? Okay, so here what data have been given? The sampling frequency is given at 200 Hz. So the sampling frequency fs, this is given 200 Hz. And students, I hope all of you know like what is the frequency domain representation of this sampled signal xst. So if I write in terms of f notation instead of omega notation, then x s of f is given by 1 by ts summation n from minus infinite to plus infinite x of f minus n fs. This is what is the generalized model of this xs in the ideal sampling case. So what is my idea is, by considering the signal x of t, okay, I'll first find what are the frequency component present at this signal. So how I'll be getting that? Using this expression, okay. Once I know what are the frequency component present here, so it's a low pass filter, I can easily figure it out what part will be passed, which part will be blocked. So let us see what are the frequency component we have in x of t. So x of t signal, if you see students, so this is given as 2 cos of 180 pi t multiplied by cos of 60 pi t. So this is like cos A into cos B model. This can be written as, okay, so this 2 is outside, this is cos A into cos B. So this is half into cos of A plus B, 180 pi t plus 60 pi t is 240 pi t plus cos of A minus B, 180 pi t minus 60 pi t. So this is basically 120 pi t. So these two to cancel out. So your x of t is cos 120 pi t plus cos 240 pi t. So, like in the cos omega naught t notation, the omega naught represents the frequency, and if I say in terms of hertz, then f naught happens to be omega naught by 2 pi. So, if I ask you what are the frequency component of this x of t, so from this component, if I divide it by 2 pi, I'll get the frequency is 60 hertz. If I divide here 2 pi, I'll get the frequency is 120 hertz. That means this signal which I am interested to sample, it is having frequency component 60 Hz and 120 Hz. And if it is sampling through a sampling frequency of 200 Hz, then what are the frequency that will appear at this one? So for that, we'll have to evaluate this particular expression. From this expression, we can figure it out what frequency component we'll have. And students, here, because my Fs is known to me, so what I'm doing is, instead of writing x of f minus nfs, so directly let me write x of f minus 200n. So simply fs value, because this 200, I have substituted it is 200. Okay, na? Fine. But I believe all of you know, like if I plot the spectrum of this x of t, so how does the spectrum look like for a sinusoidal function? They are the impulses. So suppose, for example, if I have a function cos omega naught t, if I ask you to find its spectrum, the CTFT spectrum, you'll have two impulses located at minus f naught and plus f naught. So in the CTFT, you have studied this. In other words, what I'm saying is, so this cos 120 pi t, its frequency 60 Hz, you'll be getting two impulses. One is at plus 60, one is at minus 60. So let me write plus minus 60. In the same logic, you'll get one impulse at 120, one at minus 120. So now let us see this expression, which is xs of f, which is equals to 1 by ts into summation of x of f minus nfs. So like fs is 200, this is, so n from minus infinite to plus infinite. So anyway, I mean, this amplitude is not of interest to us. Okay, we can ignore it as far as our question is concerned. Our focus is only on the frequency. So basically, I will highlight, I'll target only this particular term. Okay. So see, students, if I take n equal to 0, so the summation will give me x of f. So x of f, what are the frequency? The frequency are plus minus 60 and plus minus 120. We have already evaluated this and this. You take n equals to 1. If you take n equals to 1, so you get x of f minus 200. So what are the frequency you'll have here? So if you have x of f, if you want to get x of f minus 200, you have to add 200 everywhere. So 200 plus 60, you get 260. 200 minus 60, you get 140. 200 plus 120, you get 320. 200 minus 120, you get it is 80. I hope my calculations are correct. But instead of taking, like n of 1, you take n of minus 1. If you take minus 1 now, so here you get x of f plus 200, and equivalently, if you find it out, you will get the negative version of all this. So in other words, what I'm saying is, for n equals to plus or minus 1, okay, for n equals to plus or minus 1, the frequency component I will have is plus minus, plus minus, plus minus. So now n equals to plus or minus 2 if I take, so you get it is x of f of minus plus 400. So now you add 400 on each of these components, because you are shifting that x of f signal. So 400 plus 60 is 460. 400 minus 60 is 340. 400 plus 120 is 520. 400 minus 120 is 280. And again, if you take plus, you get the, minus 1. So you get plus minus, plus minus, plus minus. So do I need to proceed further? I don't need to proceed further. Why I need not to proceed further? Because I know my low pass filter having cutoff frequency 100 Hz. So how does the low pass filter look like? Low pass filter, if you draw its frequency response characteristics, the frequency response characteristic is, it is from minus 100 to 100. This is your f in Hertz units, and this is your 1. So basically, what is given to this low pass filter is this is the signal which is given to this low pass filter, and what frequency this signal is containing, these all frequencies is containing, and it is actually infinite. There are infinite number of components at the input of this low pass filter. Why I am not proceeding further is because the cutoff frequency is 100 Hz. If you see these numbers, they are way beyond 100. Now if you try with n x of n plus or minus 3, so it will be 600, then it will be 660, that range, too much of range beyond 100. So no need to proceed there. So like that, if you want, you can do some time pass like this, but not required. So now if you see, if these frequency components will pass through low pass filter, what will be appearing at the outputs? So I can see, so plus minus 60, so this is coming in the pass band range, so 60 is coming in the pass band range, this will be passed. Plus minus 120, they will be blocked because 120 is in this range, so they are not in the pass band. In the same logic, plus minus 260 will be blocked, this will be blocked, this will be blocked. What about this? Yes, this will be passed. And here you can see all these numbers are not in the pass band, so they all will be blocked. And again, if you try for n equal to plus minus 3, they all will be blocked. So if I ask you what are the frequency that you are getting at the output of this low pass filter, so you have plus minus 60 and plus minus 80. So plus minus 60 indicates it's a sinusoid of frequency 60, and plus minus 80 indicates it's a sinusoid of frequency 80. Like here, these two impulses which are at f0 and minus f0, these two together contribute one sinusoid of frequency f0. In the same logic, plus minus 60 represents a sinusoid of frequency 60 Hz, and plus minus 80 represents a sinusoid of frequency 80 Hz, right? So the maximum frequency present in the filtered signal in Hz is, answer is definitely 80. It is not anything else, it is 80. Maximum they are asking. What are the frequency present means 60 and 80, but maximum frequency means naturally your answer is 80. So 80 is the right answer for this problem. So this is again a student very repetitive model question, right? It's not a new model questions. In the history, if you check, at least 10 to 15 times this model question has been asked. A sample signal is passed through low pass filter with a cutoff frequency. What are the frequency that will appear at the output? So very standard general model. So the answer is 80 for this. This question is in GATE 2023 of electrical. This is from signal system subjects and from classification of signal topic. The question is, the period of the discrete time signal xn described by the equation below is n. So what is the value of n? So we are supposed to find the fundamental period of this discrete time signal x of n. So if you see, you have a DC, and addition of DC no way play any role on deciding the period of the signal, right? So this can be ignored while calculating the period of x of n. So we have to find the period of this, and you know, in the discrete case, if sinusoidal signals are added or subtracted, then the corresponding overall period of the signal is LCM of the individual period. So let us say the period of this is n1 and period of this is n2. So the overall period of the signal xn, so which is n, so n is nothing but equals to LCM of n1 and n2. That's what I want to say. So n1 is 2 pi by omega naught into m1. So if you see, so omega naught value is 15 pi by 8. So it is 2 pi by, you know, like it will be 8 by 15 pi, and this is your m1. Pi cancel out, it is 16 by 15 into m1. By selecting m1 value as 15, so your n1 value is coming as 16. And of course, because this 2 pi by omega naught is coming as ratio of to integer, there is no doubt that this is a periodic signal, right? So this is definitely periodic signal. It is satisfying the condition 2 pi omega naught is ratio of to integer. And because it is periodic, by selecting m1 value 15, we got the value of n1 as 16. So n2 happens to be 2 pi by omega naught into m2. So this equals to 2 pi into how much? 3 by pi into m2. Pi cancel out. This is 6m2. By selecting the value of m2 as 1, we got the value of n2, which is 6. So you got n1, you got n2, and addition of DC will no way play any role on deciding the overall period of this x of n. So you can simply take the LCM of 6 and 16. So 6 and 16, if you take the LCM, so this is 3 and this is 8. So that's all right. So 48. So the LCM of this 6 and 16 is 48. So the answer of this is 48. The overall period of the signal is 48. The very simple, straightforward, repetitive model question. Answer is 48. This question is in GATE 2023 of electrical. This is from signal system subjects and from DTFS topic. The question is, the discrete time Fourier transform of a signal x of n is x of omega equals to 1 plus cos omega into e raised to power minus j omega. Consider that xpn is a periodic signal of period n equals to 5 such that xpn equals to xn for n equal to 0, 1, 2 and 0 for n equals to 3, 4. Note that xp of n is given by this expression. The magnitude of Fourier series coefficient A3 is. Okay. So we are supposed to find the Fourier series coefficient of this periodic signal xp of n. Okay. So, like the DTFS coefficient AK is given by the formula 1 by n summation n from 0 to n minus 1. That signal for what we are finding the DTFS coefficient, which is xpn in this case, into e raised to power minus j 2 pi by capital N into small n k. In this case, if you see the value of n equals to 5, and in the question we are supposed to find A3, that means your k equals to 3. If you simplify this, so this is 1 by 5 summation n from 0 to 5 minus 1, which is 4, and then it is your xp of n into e raised to power minus j 2 pi by 5 3n. In fact, directly we can write this as e raised to power minus j 2 pi k value is 3, so it is 6 pi by 5n, isn't it? So if you substitute here k equals to 3, it is 6 pi by 5n, right? So now if you expand it, so this happens to be 1 by 5, okay? Now you can substitute the different value of n ranging from 0 to 4. So if I substitute n equal to 0, so you get xp of 0, and this term is e raised to power 0 is 1. Plus, if you substitute n equals to 1, xp of 1 into e raised to power, okay, how much? Minus j 6 pi by 5. Plus, if you substitute n equals to 2 now, xp of 2 into e raised to power minus j 12 pi by 5. And plus xp of 3 plus xp of 4, but they will be 0 because you see this xp n is equals to 0 for n equals to 3, 4. So if I write here the next term xp of 3 into something, so xp of 3 I know 0. Similarly, xp of 4 is also 0. So there is no point to write this again further forward. Okay. So now, if you see this, students, so basically to solve this equation, you need the data xp0, xp1 and xp2. So how do you get it? So xp of n equals to x of n for n equal to 0, 1, 2 they have given. And x of n is not given directly, its corresponding dtft is given. So from this dtft, we will be finding the idtft to get x of n for n equal to 0, 1, 2. We'll be substituting here, and then we'll again simplify this. This is a bit lengthy problem. There is one more shortcut technique, right? So if you have the DTFT of a periodic signal x of n, there is a way to get DTFS coefficient directly using some formula. But here I am not going by that approach, so I am just giving the generalized methods. Well, so let me go into a different page and let us see. Okay, fine. Yeah. So x of omega is given this one. So I can say that x of omega is e raised to power minus j omega. Okay, we can do this way. X of omega equals to 1 plus e raised to power j omega plus e raised to power minus j omega divided by 2. Or we can do this way, half of this one and plus half of this one, and this is whole multiplied by e raised to power minus j omega. Is that fine? If you multiply this e raised to power minus j omega, you get it is e raised to power minus j omega plus you get half plus half into e raised to power minus j2 omega. So if you rearrange it, so half plus e raised to power minus j omega plus half into e raised to power minus j2 omega. You know very well, like delta of n minus n naught its corresponding dt of t is e raised to power minus j omega n naught. This is what is a standard dt of t pair. So if this is what your x of omega is, so if I ask you to write what is x n, okay, so if you compare with this one, so if you make the value of n not equal to 0, that is delta of n, its corresponding dt of t will be 1. So here I can say this is half of delta n, and this is delta of n minus 1, because if you substitute here n equals to 1, you get it is e raised to power minus j omega. In the same logic, you get it is half of del of n minus 2. This is your x of n. So if I ask you to write this, what this is actually telling you, it means that x of n, this value is equals to, at n equal to 0, it is half. When n equals to 1, it is 1, because this amplitude is 1. And when n equals to 2, its value is half. So x of n description is half, 1 and half. So this was the data we need in this case. So xp n equals to x of n for n equal to 0, 1, 2. So I can see that xp of n description, if I ask you, so it is x of 0, x of 1, x of 2. So x of 0, x of 1, x of 2, half, 1, half, right? So this is half, 1, half. So this is your half, then 1, then this is half. Because x of 0 is half we got, x of 1 is 1 we got, x of 2 is half we got. Then again your x3, okay, and then they're saying that it is for n equal to 3 and 4 it is 0. That means it is comma 0, comma 0. So this data they have not given directly, but indirectly using some logic you have to find it out. So we got this xpn signal completely. So what is your xp of 0? xp of 0 is half. So we can substitute it here. So this is equals to 1 by 5 into, this is half xp of 0, plus what is xp of 1? xp of 1 is 1. So 1, and it is e raised to power minus j 6 pi, pi by pi. So we can write this as cos 6 pi by 5, right, minus j sine 6 pi by 5, plus similarly xp of 2. What is xp of 2? xp of 2 is half. So this is half of cos 12 pi by 5 minus j into half of sine 12 pi by 5. Okay, so this is what you are finding is A3 we are finding out, right? So this was AK, and this what you are finding out is A3. So this is what your A3 coefficient is. Now you have to make use of calci and you have to proceed further. So 1 by 5 into 1 by 2 is 1 by 10, which is 0.1, plus 1 by 5 is 0.2, and cos 6 pi by 5, students, if you find it out, cos 6 pi by 5, so that is coming as minus 0.809. So let me write these values. This is minus 0.809. Put the calci in the radian mode and find it out. Similarly, if you find this sine values, so this is coming as minus 0.587. So this is minus 0.587. Similarly, if you find this cos 12 pi by 5, so that is coming as 0.309. I mean this value, 0.309. And if you find this sine, this thing, so this is 0.951. 0.951. So now if you simplify this, 1 by 5 into 1 by 2 is, this is 0.1, plus this is 1 by 5 into 0.2 into minus 0.809. Okay, then you have minus j into 0.2 into minus 0.587. Okay, then again you have this 1 by 5 into 1 by 2 is 0.1 into cos 12 pi by 5, which is 0.309, and then you have minus j into, again this is 0.1 into 0.951, right? So this is what the calculation you have to do. So now if you use your calci, it is 0.1, and then 0. And this is coming as, I mean this term is coming as minus 0.16 0.18. Then it is coming as minus minus plus J 0.1174. Then this term is coming as 0.0309. Finally, it is minus of J 0.0951. If you separate the real part, this and this, summation of this is coming as minus 0.0309. And if you find the imaginary part, plus J 0.0223. So this is what your A3 is coming. But what they're asking? They're asking magnitudes. So magnitude means your A3 mod. So A3 mod, if you find it out, so it is minus 0.0309 whole square plus 0.0223 whole square. If you find it out, this is coming as 0.038. So the answer is 0.038 for this. In fact, friends, after reaching to this particular equation, it is up to you how do you simplify this. If you have some other skill of mathematics, you can reduce the calculation. Otherwise, without going into much, manipulation, this, that. So just by directly using calci also, you can get this answer. You have to agree it's a lengthy problem. Not a tough one, not at all tough. But yeah, so this from DTFT you have to get this data. That was one simple trick, and then rest of things is maths. So the answer is 0.038 for this. This question is asked in GATE 2023 of electrical. This is from signal system subjects and from LTA system topic. The question is, which of the following statement is are true? So we have 4 statements. We have to figure it out which are true, which are false. Coming to the first one, so and if an LTA system is causal, it is stable. So first thing is, what is the condition for stability? The system is said to be stable if the impulse response is absolutely summable, right? So this is the condition for stability. So they are saying that if a system is causal, it will be stable. Now, for example, if I say that h of n equals to un, if h of n equals to un, the impulse response, it look like this. This is n equal to 0, 1, 2 like this. So this is your u of n. So this is definitely a causal system because it is 0 for n less than equals to minus 1. So it is a causal system. But whether it is stable, it's not stable, it's unstable, because if you add 1 infinite time, because it's existing up to n equals to infinite, if you add 1 plus 1 plus 1 like this infinite time, it will be infinite. So it is definitely unstable system. So causality doesn't ensure stability. So if a system is causality stable, this is of course a false statement. Okay, now let us see the option C first, then we'll go to other things. So option A is gone. So if option C is saying, if a discrete time LTA system has an impulse response h of n of finite duration, the system is stable. Okay, so here what they are saying is, so if impulse response h of n of finite duration, the system is stable. Again they are saying regarding stability. So suppose, for example, your h of n is containing finite number of, finite duration means what? It is having finite number of samples. Suppose it makes sense if I have finite number of sample, and if I assume that all the sample amplitudes are finite, then if I add all those sample value, again this condition will definitely satisfy. So no matter it is A, B, C, whatever might be the amplitudes. So if you add this, so mod A plus mod B plus mod C, provided A, B, C are finite, so answer will be definitely finite, na? It will never be going to infinite. So yes, it is true. If a discrete time LTA system has impulse response h of n of finite duration, the system is stable. But here we are assuming all the sample, the amplitudes, they are of finite amplitudes. If any of the amplitude is infinite, it will not satisfy. But by default, we assume these samples are of finite amplitudes. So option C is of course representing a correct statement. So what about this option D? So if impulse response is equals to between 0 to 1 for all n, the system is stable. Okay, so if impulse response is 0 to 1 for all value of n, the system is stable. Is it correct? Now let us say that my h of n equals to 0.2 for all n. If h1 of fn is 0.2 for all n, now what do you think? Now if you substitute this 0.2 here, if you add this 0.2 infinite time, 0.2 plus 0.2 plus 0.2 infinite time, the answer is again infinite, right? So it will be again unstable system. So saying impulse response is between 0 to 1 for all n, the system is stable, this is false. Option A is false, option D is false, option C is true. And what about option B? A discrete time LTI system is causal if and only if its response to a step input un is 0 for n less than 0. So what is the meaning of it? The meaning is, so we are again interested here regarding the causality. Okay, under what condition? If its response to a unit step input is 0 for n less than 0. Now the point is this. So suppose this is your discrete time LTI system. This is your discrete time LTI system. And we are supposed to interested this system is causal. We need this system is causal. And they are saying that the input is step input. See, is causal if the response to a unit step input. So input is un. So if the input is un and this system has to be causal, and they are saying that so this response, this y of n, so this is 0 for n less than 0. Now whether it is true or false, so this is definitely true statement based on that lower limit property. That is, if you are convolving this with the impulse response of this, so sum of these lower limits will be the lower limit of y of n. So we know that u of n start with n equal to 0. U of n start with n equals to 0. So if I am saying that this y of n equal to 0 for n less than 0, so definitely this system must have the impulse response 0 for n less than 0. In other words, u of n is starting from n equal to 0, right? This is n equal to 0, 1, 2 like this. So this is your u of n is. Now h of n. So h of n, it can be any h of n. So let's say this is how the h of n is like this. So this is, let's say, like this. Now suppose for example, I am saying that this is starting at minus 1. If it is starting at minus 1, then the y of n will start at 0, minus 1, minus 1. It will start at minus 1. But they are saying that y of n is 0 for n less than 0. That means y of n equal to 0 for n less than equals to minus 1. So it makes sense, like, because this is starting at 0. So definitely this h of n is starting at some value that which is n greater than equal to 0. Now suppose for example, if I am saying that this h of n is starting at, let's say, 5, then y of n will start at 0 plus 5 equals to 5. If I am saying that this h of n is starting at 0, then this will start at 0 plus 0 equal to 0. So yes, it makes sense that if the input is step and the response is 0 for n less than 0, then this is definitely a causal system. Because if this is not causal system, if h of n is starting before n equal to 0, then this condition will not satisfy. So definitely this answer is this statement is true. This statement is true, isn't it? So that's all. So this is definitely true statements. So answers are B and C for this one. I think this is a MSQ questions. A and D are definitely wrong statements. But in the option C, it could have been better if they would have given that all the amplitudes are of a finite level. That could have been the better. But they have not given. We'll assume it is by default is true. So B is true, C is true. So A and D are false. It's a good logical question. So answer is B and C. This question is asked in GATE 2023 of electrical. This is from signal subjects and related to jet transform DTFT topic. The question is, the jet transform of a discrete signal x of n is x of z with ROC R. Which one of the following statement is true? So if you see the options, we are supposed to comment regarding existence of DTFT of the time domain function x of n. So here you can see there are 3 poles. So there are 4 possible ROCs. So among those ROCs, we are supposed to find in what case, what should be the selected ROC. so that the DTFT of x of n will converge or it will exist. So the concept here is, you know that very well, if the ROC includes, what? Unit circle, if ROC include unit circle, then DTFT of x of n exists, right? So you know this, like in the S domain, if the ROC includes j omega axis, CTFT exists. Similarly, if the ROC includes unit circle, DTFT exists. So here if you see, so let me have this, so this dotted circle is the unit circle, then the poles are existing at 1 by 5. So let's say this is your 1 by 5. This is your 1 by 5. And then one more pole is existing at 3. So let's say this is your 3. Okay, this is one case. And one more is at 2 by 3. 2 by 3 is 0.66. So let's say 0.66 is somewhere here. So this is something like this. So there are 3 poles, this one, and this one. I'm not joining it because this one will not include that pole. So that's why. And I don't know what ROC I'll be selecting. That's why I'm not able to put the curve also, whether it will be this way or this way. So that depends on the selected ROC. So first case, they are saying that mod z greater than 3. So mod z greater than 3, this is what is the ROC. So if mod z greater than 3, this highlighted ROC, is it including the dotted circle, unit circle? No. So because the ROC is not including the unit circle, if this ROC is selected, then DTFT won't exist. So option A is definitely a false statement. Option B, DTFT of x of n converges if R is between 2 by 3 to 3. So 2 by 3, this is your 2 by 3 pole and this is your 3. If the ROC is between 2 by 3 to 3, that means this is what the ROC. So you see now, if this ROC I am selecting, whether this ROC is including unit circle? Yes. So because this ROC including the unit circle, I can say that DTFT of x of n will exist in this case. So definitely B is your right answer. What option C is saying? DTFT of x of n converges if R is such that x of n is a left-sided sequence. If x of n is left-sided sequence, then the selected ROC is mod z less than 1 by 5. The smallest pole, it should be inside the smallest pole. So in that case, the ROC will be like this. This is what will be ROC. But whether this highlighted ROC including the unit circle? No. So this cannot be the answer. Option D, DTFT of x of n comes if R is such that x n is a right-sided sequence. If x of n is a right-sided sequence, the selected ROC must be mod z greater than 3. It should be outside the largest pole. So again, it is coming as option A. So it is not including the unit circle. So this is also a false statement. So answer is B for this. DTFT will exist if the selected ROC is between 2 by 3 to 3. This question is asked in GATE 2023 of electrical. This is from signal system subjects and related to Fourier transform concept. The question is, the Fourier transform x omega of signal x of t is given by x omega equals to 1 for mod omega less than w naught and 0 for mod omega greater than w naught. Which of the following statement is true? Xt tends to be an impulse as w naught tends to infinite. X naught decreases as w naught increases. At t equals to pi by 2 w naught, xt equals to minus 1 by pi. At t equals to pi by 2 omega naught, xt is equals to 1 by pi. So first of all, we have a frequency domain function x of omega. And from this x of omega, so we have to first get what is your time domain function x of t. Once we have access to x of t, then these all options we can easily decide which are correct, which are wrong. So x of omega, if I plot it graphically, how does it look like? So if you see this, from this is your omega axis, this is minus w naught, this is plus w naught. Okay, so from this x of t is equals to sine w naught t divided by pi t. So this is a standard low pass filter impulse response. Okay, so this is the frequency response low pass filter, and this is what its corresponding time domain function. This is a very standard data. Okay, fine. So let us see one by one. Let us first comment regarding this option C and D. So what they're telling is at t equals to pi by 2 w naught. So let us substitute t equals to pi by 2 w naught. So x of pi by 2 w naught is equals to sine of w naught. This is pi by 2 w naught. This is pi by pi into pi by 2 w naught. So wherever t is there, I am replacing the t by pi by 2 w naught. So I have replaced this t with this one and this t with this one. If you simplify this, how much will you get? So this w naught and this w naught are being cancelled out. So you are left with sine pi by 2, and this is pi square divided by 2 w naught. In fact, this is 2 w naught by pi square into sine pi by 2. Sine pi by 2, sine 90. Sine 90 is basically coming as 1. So this is coming as 2 w naught by pi square. That means at t equals to pi by 2 w naught, the value what we are getting is 2 w naught by pi square. So whether option C and D are correct or not, so option C is false, even option D is also false, because we expect 2 w naught by pi square, but here it is minus 1 by pi and plus 1 by pi. So of course C and D are not the right answer. Now what is the value, what about option B? X naught decreases as w naught increases. What is x naught value? So in this, if you substitute t equal to 0, so x of 0, if you see, this is coming as 0 by 0 form. So using L'Hospital rule, so x of 0 if you want, so you differentiate the numerator and denominator, then substitute t equal to 0. If you differentiate the numerator, what do you get? You get it is omega naught cos omega naught t, and if you differentiate the denominator, you get it is simply pi. So now you substitute t equal to 0. If you substitute 0, cos 0 is 1, so you get it is w naught by pi. So you see x of 0 is coming as w naught by pi. So it is saying that x of 0 decreases as w naught increases. But here they are directly proportional, right? So if w naught will increase, definitely this will also increase. If they would have inversely proportional, then it might have true. But here, because this is direct proportional to w naught, when w naught increases, x naught also increases. It will not happen like this is increasing, this is decreasing, right? So of course, as usual, option B is also wrong. So correct answer has to be option A. What option A is telling? X of t tends to be an impulse as w naught tends to infinite. So what is the property of impulse? So if you remember, impulse function, if you remember delta t description, so its value is infinite when t is equals to 0. Its value is 0 when t is not equal to 0. And the area of this function delta t dt, so that happens to be 1. This is what is the generalized definition of the impulse function. Now what it is telling? So when omega naught tends to infinite, x of t tends to be impulse. When omega naught tends to infinite, you see, now don't you think that x of 0 is, we got it is w naught by pi. So if you are making this w naught value, infinite, so naturally this value is also infinite. Infinite by pi is again infinite. So that means, so as w naught tends to infinite, so you see that this amplitude, which is x of 0, that is at time t equal to 0, the amplitude is tending to infinite, right? And what about how do you answer about this one? So by the way, if you plot this function, student, the sine w naught t by pi t, if you plot it, so how does the curve will look like? So this is like a sinc function, if you remember. So this is how it will look like. Okay, so this crossing points, it will be coming as pi by omega naught. This is 2 pi by omega naught, and so on and so forth. This is minus pi by omega naught. This is minus 2 pi by omega naught, and so on and so on. These are zero crossing point. How do you get it? You simply equate this particular numerator to 0. W naught t is equals to n pi. So t is equals to n pi by w naught. So pi by omega naught, 2 pi by omega naught, you'll get like this. Omega naught or w naught, whatever you say. So now you see, like this width is pi by how much? W naught, right? But when w naught tends to 0, Don't you think this width will be tending to 0? Pi by W naught is this one. So that means what? This width, because this is the time axis and this is time t equal to 0. So this gap, if I ask you how much this is pi by W naught. Now, if you make omega naught tends to infinite, so this ratio will be tending to 0. If this ratio tending to 0 means what? This, I mean, the width of this signal becoming 0. Not only this, you see every crossing point, these all will be tending to 0. So they will be existing at a single point. So basically, these all points that will be coming to the origin, so the width of the signal is becoming 0. That is what is the meaning that x of 0 is equals to 0 if t is not equals to 0. Right? X of 0 is infinite we got from this relation, and x of 0 becomes 0 when t not equal to 0, because when t is not equal to 0, you see, like when omega not tend to infinite, so the width will become 0. So the signal will exist only at origin. So if it is existing only at origin, other than origin it won't exist. So that is the meaning that when t is not equal to 0, x of 0 is 0. And one more thing, students, so if I ask you what is the area of this curve, what is the area of this x of t, so that area is basically 1. How do you say 1? So using that central ordinate property, you might be knowing that integration of x of t dt, this equals to x of 0. So if you are integrating this function, okay, this is equivalent to finding the amplitude of this signal at omega not equal to 0. So that omega not equal to 0, the amplitude is 1. So area of this function is 1. So area of x of t dt, so that equals to 1. So this is nothing but the classic case of the impulse. So what is happening when W naught tends to infinite? So height is becoming infinite, width is becoming 0, and the area is 1. So that is what is the characteristic of impulse function, and that's what is happening. So answer has to be option A. So understanding option A, if you have good idea regarding how impulse is generated, that is fine, you can easily figure it out. Otherwise, by elimination of option also, B, C, D are anyway false, which is straight away visible, you can tick A as the right answer. So answer is option A. It's somewhat okay, good logical question, not much tough. This question is asked in GATE 2023 of electrical. This is from signal system subjects and from LT system topic. The question is for the signal x of t and yt shown in the figure, zt equals to x of t convolution with yt is maximum at t equals to t1, then t1 in second is dash. So student, so z of t is given as x of t convolution with y of t. So if you expand its convolution integral, it is minus infinite to infinite y of tau x of minus tau plus t d tau. You can write this as x of tau into y of minus tau plus t, but x of t waveform is given a square waveform, rectangular pulse. So folding, shifting, etc. is bit convenient in rectangular pulse compared to other pulses. That's why I am selecting this as for folding and shifting. Although I would have option to do this as well. Okay, so this is zt, but here we are not interested to find what is the waveform of zt or what is zt for all value of time. So rather our interest is at a particular time instant t1. So if I ask you what is z of t1, so this happens to be integration minus infinite to infinite y of tau x of minus tau plus t1, and this is d tau. And if you know very well, so integrations always gives the area under the curve. So z of t1 happens to be area under product of y tau and x of minus tau plus t1. Okay, so this is your yt. So if I ask you to draw y tau, so simply this is y tau, and this axis which is t earlier, this become tau. So this is tau. Now let us try to plot this x of minus tau plus t1. See, x of t is given like this. This is what your x of t is given, which is covering from minus 1 to 1. This is the time axis. This is your x of t's. But now I don't need x of t, I need x of tau. So if you need x of tau, this axis become tau, and this is x of tau. Now what about x of minus tau? X of minus tau, because it's an even function, if you fold it, if you draw x of minus tau, it will remain same. So this is x of minus tau. This is again from minus 1 to 1. But now if I ask you, you draw x of minus tau plus t1. So what is going to happen then? So the change what you're going to get is this time index which was minus 1 to 1. So this will be minus 1 plus t1 and this will be 1 plus t1. Depending on the value of t1, if t1 is positive, you'll feel that this waveform is right shifted so that you will get it. If t1 is negative, this waveform will be left shift, you will get this. So this is what the thing is, students. So y tau waveform, so let me draw it separately. So y tau waveform is like this. It is covering from, okay, it is like this, right? This is 1, this is 3, this is 5. This is what waveform? This is the waveform of y of tau. This is the tau axis. This amplitude is minus 2 and this amplitude is plus 2. And what is this x of minus tau plus t1? So x of minus tau plus t1, we don't know what is the value of t1, but anyway, so let us assume that t1 equal to 0. So only for understanding purpose, we'll see then what is going to happen. If t1 equal to 0, it will be from minus 1 to plus 1. If t1 is not 0, so it is minus 1 plus t1, it is 1 plus t1, right? Now you see, so you have y tau waveform, you have x of minus tau plus t1 waveform. Now we need the area of product of these two. Now you think yourself, if I make t1 equal to 0, so this pulse will cover from minus 1 to 1. So if you multiply this and this, you will get 0. Because this waveform is coming 0, so area under 0 is anyway 0, because there is no area. But now you imagine, suppose I am making t1 equals to how much? Let us say that I am making t1 equals to 2. So now if I make t1 equals to 2, now what is going to happen? If you make t1 equals to 2, so now this pulse, so this will cover from where to where this will cover, sir? So if you make t1 equals to 2, so it will cover from 1 to 3. So 1 to 3 it will cover like this. So this is 1 and this is 3 and this height is 1. So now if you multiply these two, I mean what? To what? This and this waveform. If you multiply like this, so you are going to get this waveform, because if you are multiplying anything with 1 is anything. This is anything, you are multiplying with 1, you get anything. So the answer will be area of this function. So this will be some negative answer because amplitude is negative. Now you imagine a case, instead of taking t1 equals to 2, if you would have taken t1 equals to, let's say, you would have taken it is 1, then what would have happened? If it would have, you had taken 1, then this waveform would have been covered from where to where? It would have covered from where to where it should have covered. So if you take t1 equals to 1, so this will be covering from from 0 to, if you take t1 equals to 1, this will cover from 0 to 1, right? Okay, it's of no use. Now let's say you take t1 equals to 3, if you take t1 equal to 3, now the waveform will cover from 2 to how much? 4. It will cover from 2 to 4. So if it is covering from 2 to 4, so then what is the point then? So the point is 2 to 4 means 2 is somewhere here and 4 is somewhere here. So now if you check, so if you multiply this waveform with this waveform, this is 2 and this is 4. So what you will get? So at 2 this is the shape, at 4 this is the shape. So something like this you will get. So the total area, if you find, it will be 0. So ultimately, if you understood how it is happening, if I am introducing the shift, how I am getting the area, so I believe you can easily feel it now, that if I make t1 equals to 4, then I will be getting the maximum amplitude. How? If I make t1 equals to 4, the change is this point minus 1 plus t1, this will be from how much? 4 minus 1, this will be 3 and this will be 5. So this pulse will now cover from 3 to 5, and in the range of 3 to 5, so this pulse will come from 3 to 5. If you multiply this and this, you are going to get this right angle triangle, and the area of this will be maximum. See, I have shown you this by taking t1 value something, I got some negative answer. I have taken how much that value I have taken. I think t1 I have taken this as how much I have taken that time. I think I have taken 2. I have taken t1 equals to 2, and I have shown you I captured only this, I got the negative answer. Now if you are expecting maximum answer, you can see that if you take the value of t1 in such a way that this will capture this triangle, so product of that will be maximum. So that is what will get maximum. So naturally, if you take t1 equals to 4, So this pulse will now cover from where to where? This pulse is now covering from 3 to 5. So this is from 3 to 5. So this is what waveform? This is the waveform of x of minus tau plus t1. T1 is basically 4 in this case. You multiply these two. If you multiply these two, you are going to get this right angle triangle. So this area you'll get. So this amplitude is 2. This is your 5. This is your 3. So the answer is half into base into height. The answer is 2. So the maximum value you are getting 2. And when you are getting? When the value of T1 is becoming 4. So it is very evident, students. So like, because the rectangular pulse is covering from where to where? Minus 1 plus T1 to 1 plus T1. So your idea should be, because this width is 2. This width is 2. And this width is also 2. You should adjust this T1 in such a way that this 2 will be overlapping with this 2. So because you are expecting area of this one. So basically you are expecting intersection, because if there is intersection, if there is more overlapping, so you have chances to get more area. And that to be, you should be careful that if both of the amplitudes are same, either both are positive or both are negative, then you will get maximum value. If one is positive, one is negative, you are going to get negative value, the way it was happened for T1 equals to 2. So that's why I figured out, anyway, this is positive and this is positive in the interval of 3 to 5. So if I select the value of T1 so that maximum overlap happens when I've taken T1 equals to 4. So this entire area I'm capturing, which is coming as 2. So the answer of this is T1 equals to 4. It's a good logical question. Because I'm explaining, I have taken around 7-8 minutes of time. But if you solve this problem in proper flow, it should not be much more than 2 minutes of time. So answer is 4 for this.